Hello, this is Mr. Best. Welcome to Chapter 4, Trigonometry and Probability in CCG. We're going to do homework questions 6 through 11. Question 6. Use what you know about the angles of a triangle to find the value of x and the angles in each triangle below. So let's take a look here. We're trying to find the value of x. So we know that the triangle angle sum theorem allows us to say that the three angles of a triangle add up to 180 degrees. So we can say that 180 minus 79 minus 90, because it is a right angle. And if we subtract, that will give us the third angle of the triangle, which is x. So therefore, when you subtract, you get x is equal to 11 degrees. On part B, you have the two angles are congruent to each other, and they're both x. So we can say x plus 90 degrees is equal to 180 degrees. So that is 2x, if you subtract the 90, is equal to 90 degrees divided by 2, and x would be 45 degrees. On part C and D, I'm going to show you something a little different. Even though we know all of the angles add up to equal 180, if it is a right angle, we know this is 90 degrees. So that leaves us with the two other angles have to also be 90. So the other thing you could do is say that 2x plus x is equal to 90 degrees. And that will only be true with a right angle, because with a right angle, or a right triangle, because with a right triangle, you know that this angle is 90 degrees. So the other two, 180 minus 90 is 90 degrees. So a little bit of a shorter way to maybe do it, but either way is fine. And we do find that x is 30 degrees on this one. And then on D, we could do the same thing. We can say x plus 22 degrees is equal to 90 degrees. And then if you subtract 22 degrees, you get x equals 68 degrees. And so as I kind of reread the directions here, it does say to find the value of x, which we did, and the angles in the triangle below. So the first one, x equals 11, that is the angle, because that's what x is. Same thing with B, x is equal to 45 degrees. Well, because both of these represent x, these both represent the 45 degrees. For C, x is equal to 30 degrees. Well, that means this is 30 degrees, but then this one up here would be 60 degrees. And then for D, x equals 68. That means this is 68 degrees. So just in case, I want to make sure I labeled all those angles in the triangle as well. Question 7. Use the triangles below to answer the following questions. Are the triangles above similar? How do you know? Show your reasoning in a flow chart. So what we're looking at with these two angles, we see that angle B and angle E are congruent. We also see that angle A and angle D also are congruent or have the same measure. So we do know by angle similarity that the two triangles are similar. So how do we know that? We want to show a flow chart. So what things do we know? We know that the measure of angle A is equal to the measure of angle D. We also know that the measure of angle B is equal to the measure of angle E. And we only need two angles, because if these are equal, then we know that the third one will also be equal. So we have that, which allows us to say that triangle ABC is similar to triangle, once again, make sure you match up the correct angle measures. So A matches up with D, B matches up with E, and then C would match up with F. So triangle ABC is similar to triangle DEF. Make sure you draw your arrows. And we know that because of angle similarity. All right, part B. Examine your work from part A. Are the triangles also congruent? Explain why or why not. So are the triangles also congruent? Well, if we look at side AC, that will match up with side DF. So when we go to do the ratio, we have 4 over 4, which is equal to 1. So with knowing that, since the corresponding side lengths have a ratio of 1, then yes, the triangles will also be congruent as well. And so make sure you explain why that is true. Question 8. As Randy started to solve for x in the diagram below, she wrote the equation 7 squared plus x squared equals x plus 1 squared. Is Randy's equation valid? Explain your thinking. So because this is a right triangle, you have your leg of the right triangle, and here's your other leg. So those squared, which is your 7 squared plus your x squared, should equal the hypotenuse squared. And since the hypotenuse is in the form of x plus 1, it also gets squared. So yes, she used Pythagorean theorem to set that equation up. Part B, to solve her equation, first rewrite x plus 1 squared by multiplying the two binomials together. You may want to review the math notes for lesson 222. So on part B, we can use the generic rectangle or the distributive property. So we have 7 squared is 49 plus x squared, we don't know, and then x plus 1 times x plus 1 would be x squared plus 2x plus 1. That's where you can use your generic rectangle to figure that out. So now on part C, it wants us to go ahead and solve for x, so we can do that. We'll subtract the x squared, so this really is now part C. 49 is equal to 2x plus 1 because the x squareds cancel. We could subtract 1 to get 48 equals 2x, divide by 2, and x is equal to 24. Part D, what is the perimeter of Randy's triangle? So let's take a look. We got to fill in the values that we now know. If x is 24, this side length is 24. 24 plus 1 is 25. So now we know that the perimeter is 7 plus 24 plus 25. So that would be, let's see, 49 add 7 is 56. And it is perimeter, so we got 56 units. Make sure you're always labeling. Question 9. Assume that the shapes below are similar. Find the values of x, y, and z. So we are assuming that they are similar, so we can match up the corresponding sides. So 8 over 12. So I took this one over this one. And then that ratio should be the same as z over 10, which is equal to this one over this one, but we don't have those side links, so we're going to move on to the next one. And then that would be y over 6 is equal to 6 over x. So it's important that you get those ratios set up correctly. Now, it doesn't matter if you go from the small to the large or the large to the small. If we're not looking for the zoom factor, we're just looking to find the values. We can go in any order. Just make sure you're consistent with it. So 8/12, I'm going to reduce that by 4, so make the numbers a little bit smaller. It'd be 2/3. So I'm going to use 2/3 is equal to z divided by 10. And then I'm going to solve this, and then that will find the value of z. So we get 20 is equal to 3z, divide by 3, and z would be equal to 20 over 3 as a mixed number. That's going to be 6 2/3. I'm going to leave it like that. Decimal would be repeating, so that's z. Now I'm also going to use 2 over 3, and then the y over 6. So this will give us 12 is equal to 3y. Divide by 3, y is equal to 4. And then I'll continue to use the 2/3 because that's what was given to us. And then the 6 over x. And then this one I'll get 2x is equal to 18. X is equal to 9. Question 10. Roll and win. You begin the game roll and win by picking a number. Then you roll the 2 regular dice, each numbered 1 through 6. You add the numbers that come up together. If the sum is the number you chose, you win a point. For example, if you choose 11 and a 6 and a 5 are rolled, you win. What is the sample space which can be thought of as the set of all possible outcomes when 2 dice are rolled and their numbers added? So we're looking for the possible outcomes when you add 2 dice together. So the smallest you could have is 1 plus 1 is 2. And then you could have 1 and 2 is 3. And then you can just continue on here. You're going to get 4, 5, and 6. And then what's the highest? What's the largest you can get? 6 and 6 is 12. So we can go all the way up to 12. So you can't ever roll a sum of 1 or anything greater than 12. So that's the sample space. Those are the possibilities there. One way to analyze this situation is to make a model of all the possible outcomes like the one below. Copy and complete this table of sums on your paper. Are each of the outcomes in this table equally likely to happen? So let's go ahead and fill out our possibilities. 1 and 1 is 2. And I'm gonna pause the video and go ahead and fill them all in, but you're just doing the sums of each of these. Alright, so I went ahead and filled out the table, and you can take a look at, each of those, and you'll notice some of the sums are definitely happening more often than are not. So it says, are each of the outcomes in this table equally likely to happen? So each of the outcomes are equally likely to happen in the sense of rolling the dice. There's no, like you're not going to get a 4 more often than you get a 1 or something like that. So each of these individual outcomes, and I'm talking about each individual outcome, is equally likely to happen. And there are a total of 36 outcomes that could occur, even though these are the only possible outcomes out of those 36. So on B, what is the probability that you will roll an even sum? So then you're just going to sit here and look at your even sums. You have 2, then you have this one, which is your 4s, your 6s, your 8s, your 10s, and your 12s. So add that up. Out of 36, how many are there? So we have 1, then we have a 3, so that's 4. Add the 5, that's 9. Where am I at? 14. 18, I think I hopefully did that correctly. So the probability to roll an even, there's 18 possible even combinations out of a total of 36. Okay, and we could reduce that, but I want to leave it as 18 over 36 so you can see out of the possibilities, out of the possible outcomes. The next is, what's the probability of rolling a sum of 10? So you can see your probability of rolling a sum of 10 is right here. There's 3 possibilities out of a total of 36. So once again, we could reduce that to 1/12, but we're going to leave it that way. So 3 out of 36. And then we're going to do the probability of rolling a 15. Well, we already said earlier the largest you can roll is a 12, so that would be 0 out of 36. So it's impossible to roll a sum of 15 with 2 dice. All right, let's move on to D. Which sum is the most likely result? So as you look through this, which one appears to be happening the most? Look at all, you have 2, and then you have 2s, 3s, 4s, 5s, 6s, and then right down this diagonal you have all of those 7s. So it's the 7 that appears to be happening the most. So the sum of 7 is the one that's most likely to occur. What is the probability of rolling that sum? Well, we have 1, 2, 3, 4, 5, 6 possibilities out of 36. And if we reduce that would be 1 out of every 6. That's the best. If you're playing this game, you'd want to pick a 7 because that's your best probability in terms of rolling that sum every single time. Question 11. The temperature in San Antonio, Texas is currently 77 degrees Fahrenheit and is increasing at 3 degrees per hour. The current temperature in Bombay, India is 92 degrees Fahrenheit and the temperature is dropping 2 degrees per hour. When will it be as hot in San Antonio as it is in Bombay? What will the temperature be? So we have 2 different scenarios. We have San Antonio and Bombay. And so the temperature in Texas is 77 degrees, is increasing 3 degrees per hour. So we need to set up some variables here. Let's just say T is going to equal the temperature. And the temperature is in Fahrenheit. And then we're going to we have time, and it's in hours, so we'll use H as the number of hours for that. And now we can kind of set up 2 different ones. So in San Antonio, Texas, we're going to say that the temperature is equal to, it's increasing 3 degrees per hour plus the 77 degrees that you are currently at. And then on the other equation for Bombay, the temperature is 92 degrees, but it's dropping 2 degrees per hour there. Okay? So when will it be as hot in San Antonio as Bombay? We were trying to figure out when those temperatures will be the same. So we can set up an equation, and we can either look at it as a system of equations. We can use the equal value method and set the two temperatures expressions to each other so we can solve for when they are the same. If we add 2h to both sides, that's 5h. And then we have 5h plus 77 degrees is equal to 92 degrees Fahrenheit. Subtract 77 degrees. And then we'll have 5h is equal to 15 degrees. Divide by 5. And h is equal to 3. So we're looking at 3 hours that it will take for those temperatures to be the same. So we know the temperature will be the same in 3 hours. What will that temperature be? So we can plug that into either one of the equations. I'll just go ahead and plug it into the one from Bombay, India. So negative 2 times 3 plus 92. So therefore the temperature is negative 6 plus 92. And that will be 86 degrees. Just to show you that it doesn't matter which one you plug it into, if I take 3 times 3 and then plus the 77, that's 9 plus 77, which is also 86. So it doesn't matter which one because we know they occur at 3 hours apiece. So let's make sure we answer the question. When will it be as hot in Bombay? It'll be in 3 hours, and the temperature will be 86 degrees Fahrenheit.